Hey guys, in this video we're going to be covering Target 3D.1. Our master learning objective is I can determine the number of solutions for a linear quadratic system by using technology to analyze the graph. So we're using technology, which means if you do not have your calculator, please go ahead and pause the video and grab yourself a calculator. Some definitions. System of equations. So this is just a problem with two or more equations. So we might be graphing 2 at a time, 3 at a time. A system just means you're graphing more than one thing. So together on the graph at the same time creates a system. So number of solutions. Number of solutions tells you how many times they intersect, right? So this is what you're going to think of. How many times they intersect. So that's what we're thinking of. So if you have a system and you graph something and you get no solution, well, look at that graph to the side of it. No solution means that the parabola, right, because we have this parabola right here, right, so the parabola and line never cross. Or you can think touch, or you can think intersect, right? So when you have a no solution, they never cross or touch, which is what we see, right? That parabola never touched that line. If we have something that is one solution, well, again, we see that parabola here, and we see that linear equation, so it looks like they touch at one point. So the parabola here and the line touch once. So again, if we have one solution, we touch once. Two solutions. Well, we kind of should hopefully start seeing a pattern. If I have this parabola and this line, count how many times they intersect, right? So what we have for here is our parabola and our line cross twice. The parabola and line touch twice. Right? Again, we see that two solutions, and it's because it touches twice. All right, so this whole section is being able to determine how many solutions we have, and we have to be good at graphing these. So we have to graph two things at one time. So in our calculator, what we can do here, hopefully we're getting good at graphing. We're going to go home. We're going to go to New Document, and we want to add a graph. All right, so our first function is going to be this one in our first example, right? Because it asks us to draw the graph and determine the number of solutions. So I'm just going to go ahead and type in that first equation here, which is x squared plus x minus 2. So if I click enter, it graphs one of them, which we can go ahead and start plotting those points. So we don't need to find those x-intercepts because what we see on our scale is that they're going up one by one, right? So I'm going to go ahead and graph these points. So let's look at that first x-intercept, which is over at -2. So I'm going to go ahead and put a point close to -2 as I can. -2. And then the other point is at a +1. And my vertex looks like it's crossing over at like a -2. Right? So this is going to be my first part of my system, right? That's a parabola. So this is what's done in blue. Okay, now we want to graph the other same. So on our calculator, don't get rid of it. What you're going to do is press Control and then click G. So that's going to pop up another equation. So you're going to see like an F2 there. If you ever want to make changes to F1, you can just simply tab upward. But we want to add a different one. So that's why I want to go back to F2. And I'm going to type in that second equation. So negative x plus 1. Click Enter. And then I have that equation as well. So I'm going to try to graph this one. And it looks like I have that intersection point at positive 1. And at negative 3, positive. Okay, so just to be sure, I'm going to go ahead and draw that y-intercept, and I'm going to draw my line eventually so that I can see where exactly they intersect at. So this is my rough sketch here. And we can count, we obviously see that they intersect at one point, right? At that 1, 0 point, right? This is, so we see that one point where they do intersect. Try to highlight it, but instead I just put a line through it. Right? This is that first point that they intersect. And we want to find the other one. So yes, you could count, but there is a way to do it on our calculator. So to follow along, what we're going to do is click Menu. And we want to go down to Analyze Graph. And we want to go to number 4 where it says Intersection. So intersection, again, we see that little dotted line. So I see, if you see my little hand, that's where they intersect. But I need to be just left of it, click Enter, and then go right of it and click Enter again. And now it gives us that intersection point, which is negative 3, 4. So that's the other one that I am going to write down, negative 3, 4. So that means that this system has 2 solutions. Now, the other thing you could write for yourself is the way that we did our graph. So if you ever need to redo this, you can click Menu. You go down to number 6 that says Analyze Graph. Then you go to number 4 where it says Intersection. Alright, so those are the rules, our plans, procedures to try to get our 2 intersection points. So again, this intersection point was wherever they touched here. Alright, so let's practice again. Let's try to graph these 2 equations and go ahead and plot our 2 graphs. So you can start our graphing over by pressing the home button, go to New Document, and no, we don't want to save. And we get a new F1 and F2. Otherwise, you could have just do the Control G and just go upwards and delete, but sometimes we forget to delete something and you might get the wrong answer. So let's go ahead and type in these 2 equations. So 2x squared plus 3. Now for this one, yes, I could push Enter and do the Control G again, or I can just press the arrow downward, which automatically brings up F2. So that's kind of the easiest way that you can kind of see when we are graphing these, because save yourself the time of typing some stuff. So our parabola, right, I'm going to graph that one in blue. Looks like it was being crossed the y-axis at positive 3, and it kind of just goes up from there. Right, I would just graph important things like the y-axis and the x-axis. And then our y equaling 3 is a horizontal line. So this is just crossing through here. And for this one, we might not even need to do that intersection point. We can if you want to check it, but you can actually just see that wherever they intersect is going to be right here at 0, 3. Right? Remember, we go over on the x and then up and down. So this only has one solution. And what is our solution? Right? 0, -3. Nice, easy peasy. Sometimes you don't even have to do the intersection things. You can just see on our graph right away. All right, example number 2. Oh, actually, let's look. There's all examples number 2. So this should be example number 3. We want to graph these. So again, I'm going to show you instead of doing the whole home new document. If you want to do that, that's fine. Otherwise, you can just click Control G, and you have to tab up to F2 and delete what's there, without deleting the equal sign like I just did. And then if you go to F1, delete what's there as well, and now you can type in your new equation. So x minus 4. Like I said, I think it's easiest to just kind of go back and do it again, but whatever you'd like. Control G, type in F2, so that's going to be 2x squared plus x, enter. So 2x squared plus x. So the first one that I graphed was my x minus 4. So this was crossing my x-axis at a negative 4, crossing, or my y-axis at negative 4, and my x-axis is crossing at a positive 4. So that's this line. Alright, and then my quadratic here, 2x squared plus x, is somewhere over here. Well, do they ever intersect? Are they ever touching? Nope. So we say that there is no solution here. They do not cross or touch, so no solution. We only have to put wherever they intersect. Alright, the last example here. I'm going to go ahead and graph these ones. So I'm just going to do the menu, new document. No, I don't want to save. I want to add a graph. And start typing this in. So x squared plus 5x minus 1, enter. And then let's go ahead and graph that one first, just so I don't confuse what I was graphed first or second. So this one, it looks like it's intersecting a little past the 1, 2, 3, 4, 5. Kind of like a little past the 5. So this would be one that I definitely do the menu intersection point so that I can get the accurate intersection, because it's kind of not exactly at that negative 5 and not exactly at 0. And then somewhere past 7. So it's going to look something like this. I'm going to go ahead and graph the other equation. So Control G. Type in 2x minus 1. And that's going to be my second equation here. So it looks like it's crossing somewhere just after that point. And it looks like it's going to be somewhere over here. So we can draw that line. And we're going to see wherever they intersect. So I'm going to click Menu, Analyze Graph, Intersection. And I'm going to find this point first. So I want to be just left of it. Oops, my apology, I clicked on something wrong. So Analyze Graph, Intersection. So I want to go after it and before it. So this point right here looks like it's at 0, negative 1. So 0, comma, negative 1. So that's this point right here, wherever they intersect. And then I want to see where they intersect down here. So I'm going to do Menu again, go over to Analyze Graph, Intersection. So it's somewhere over here, right? So I'm going to go a little bit to the left and a little bit to the right. And it kind of changes my window here to be negative 3, 7, negative 3, negative 7. So I actually kind of drew my green one wrong, so let me fix that, because they should be at negative 3, negative 7. I'm going to actually regraph these. It's not allowing me to erase it now. Alright, so finally got these two right. So this is crossing over, like a little bit over here. This one was like a little bit over here. But we knew they intersect both at this point. And this is a little bit lower than that 3, -7. Somewhere down here. And then my 1 is also going through this point and through 3, -7. Right, and they're going to intersect at that point right there. So obviously it's a little bit easier. You guys can make it a little bit more accurate. And go ahead and try these. We have 2 solutions here, right? So my answer for this system were 2 solutions that they crossed 2 times. And that brings us to the end of this video. So go ahead and finish up Target 3D.1 activity, and good luck.